Chapter 11 is venture capital methods, and we're going to do 3 passes at a simple idea, which is what happens when a venture capitalist invests money in your company? How is the dilution determined? And what happens as we add different layers of complications, such as putting a stock option pool for future employees? And also what happens if you project to need 2 rounds of capital and not just 1? So learning objective 1 is the VC method. Then we're going to apply it in 3 successive learning objectives. Learning objective 2 is the simple case of what happens if there's 1 round of financing from a venture capitalist, no option pool, and no more money needed. Learning objective 3 is slightly more complex, is let's add a stock option pool for future employees and managers. And LO4 is cap table with 2 rounds of financing and also an option. At a high level, this is what we're going to do. We're going to say there are only 2 cash flow events for a venture capitalist. First is we put money in the beginning. That's a T0 negative cash flow. And then there's a liquidity event. At some point there's an IPO or mergers and acquisition transaction, in which case they get money. So the VC gets money. They can compute the rate of return for the cash out and the cash in, and that will determine their yield. Now, we work in reverse when it comes to the valuation. The VC projects what is the expected value of this enterprise and their share, and how much are they putting in. And this will determine the valuation and how much they need in terms of percentage ownership. First, we're going to say, what is the value at exit based on some projected business and comparables? Second is, how much money do we need? And based on that, how much do they get, they being the venture capitalists? Then we'll work through all the math to do what's called a capitalization table, which is showing who are the owners, what percent, and how many shares. So we're going to use a standard format for each of these 3. So we're going to start with this case, which is the basic scenario. So this is 1 funding, then an exit, no additional funding, and no option pool, with the following assumptions. First, that the founders have 2 million shares before the financing, that the funding required from the VC is $1 million, that the rate of return, since it's such an early stage, is 50% per year in their required return. Next, it will take 5 years from now to exit and reach an harvesting event, that the projected exit will be at a time when the venture is making $1 million in income at year 5, and that similar ventures, as our company, will have the following comparable, that there's a sales price of $32 million for a company similar to ours, but with double the income at $2 million income. So the steps we're going to look at are, what's the valuation of the company itself and then of the VC's interest? Step 2 is, what is the ownership of the VC and the founders and the price per share? And then step 3 is to complete a well-organized and clear capitalization table. So we're going to hop in and out of Excel during this particular lecture. All right, so if we look at this tab, it's exactly the same as what we saw in the PowerPoint slide. And what we see here is the scenario. And the first expansion we'll do is step 1. So we're going to determine the valuation using the venture capital method. So I'm going to go through this in the spreadsheet, and I'll upload both a blank and a completed one. The blank if you want to do it on your own and try it out. All right, so first, to determine what is the value of the company at exit. So we have a comparable. We were given that there's a comparable that had a sale price of $32 million, that the income of the company at the time of the transaction was $2 million, and from that we can use a valuation multiple of, for every dollar of income, what is the dollar value in terms of market value. So it's market value divided by income. So that's 16. So for every dollar of income, this comparable company receives $16 in value. Next, we're going to say, well, what happens if this holds for us, that we're able to accomplish our target at year 5 of $1 million income? And if we are able to get the 16 times, then we can estimate what our company's worth in 5 years. So 1 million times $16 of value for every dollar of income means our company will be worth $16 million at year 5. Sounds easy, doesn't it? Next, we'll look at the valuation from the standpoint of the venture capitalist investment. So their required return, as stated, was 50%. So let's pull that forward. The number of years is 5, so we'll pull that forward. Now here's the first calculation we have to do. If the company is worth 16 million at year 5, what is it worth today? So we go equals PV, open parens, the rate of return is 50%, comma, the number of periods is 5, comma, the payments are 0, there's no cash flow until the end, comma, the future value is 16. So when we do that calculation, we see that the company is worth $2.1 million today, right? So that's the first step. The company as a whole, this is worth $16 million at year 5, and that corresponds to a valuation of $2.1 million at time 0. All right, next step is step 2. Let's look at the VC ownership. So first of all, let's put in here the investment that they put in. They put out of their pocket $1 million. So they have $1 million out. Their required return, again, is 50%. Their years are 5. And the future value of what that's worth, or what that needs to be worth to make it worth their while, that 50%, is a future value calculation. So plus FV, open parens, the rate is 50%, comma, the number of periods is 5, comma, payments are 0, comma, the PV is investment of $1 million, so that is worth $7.5 million at exit. So when we look at the total value of the company, the percentage ownership is $7 million divided by the value of the company at exit, which is $16 million. So they need to own 47.46% of the company. Just working backwards, it would be like they buy stock and they own 47.46% of the company. At year 5, when we sell this company for 16 million, they get 47% of 16 million, which is this number, which corresponds to them earning a yield of 50% for 5 years on $1 million, right? So that's kind of forward and backwards to show how it all works. So the venture capitalist ownership will be, in this case, 47%, and they will have total valuation of $7 million. All right. The option pool at this point is 0. We'll loosen that constraint next example. And the founders will own the difference. So they will own 52.5391% of the company. So 47 for the venture capitalists, and let's just make it simpler, 52.54 for the founders of the company. All right, so that's the percentages. Now we have to figure out the number of shares. So what is the total amount owned by founders after the pool is established? In this case, there is no pool. So they will own this amount. Next is total shares, and we were given this. The total shares that they had was 2 million shares. And so therefore the total outstanding shares have to be 2 million divided by 52.54. So the number of shares will equal 3.8 million shares. So we're going to have to issue the difference to the venture capitalists. So the value per share, the value of the company, we determined earlier, was equal to this $2 million. The number of shares outstanding is 3.8. So the price per share is dollars per share, or 55 cents. So now we've established the percentage owned by the VC, the number of shares that will be issued to the VC, and what is the price per share. Now we're ready to do the cap table. So the cap table, as mentioned, is just an organized way to see who owns what. So we'll start with Series A because that's where we're at. The percent they own is 47%. The common shareholders will own 54%. The number of shares owned by the common shareholders is what they've always had, 2 million. And so therefore the total equals 2 million divided by the 52%, or 3.8. And so the number of shares owned by the VC is their percent times the total shares. And just to round this out, we'll do a sum command equals sum. You can almost see that equals 100%. So we're good. Now, on a dollar basis, the price per share we just established here is 55 cents. And that's true for everybody because at that moment, everyone has the same stock. So at this financing, 55 cents per share. The dollar value corresponding to the shares from the VC, we know the answer, but let's do it as a check. 55 cents per share times this number of shares. What should it be? $1 million. Thank God it is. So that's what they get for their $1 million. At 55 cents a share, they will get 1.8 million shares for their $1 million. For the founders, same dollars per share times 2 million. And so it's 1,000,001. And so the total value equals sum is what we determined previously, the 2.1 million number. Okay, so that's the first step. Hopefully that was very straightforward. What we're going to be doing is using this format, and we'll watch what happens as things evolve in this cap table. We're going to be adding first the option pool, so we're going to add shares for them. Then we're going to assume that we need 2 rounds of financing and add what they get. And guess who it comes out of? The entrepreneur. All right, in the book, there are some shortcuts. And I'm not a real fan of shortcuts because I kind of like to see the numbers evolve, partly to check my own work and partly because the intermediate values are of interest. But if you want to check out the formulas, they do work. The number of shares to be issued would be the shares to the VC equals the founder shares times the acquired percent divided by 1 minus the acquired percent. And what this corresponds to is the same thing we saw before. The number of shares is 1.8 million shares to the venture capitalists. If we do price per share, it's saying, okay, the venture capitalists put in $1 million divided by 1.8 million shares, and that's 55 cents. Right? So again, we could do the math, but I like the spreadsheet method better because it leads to kind of intermediate results and a cap table that shows who owes what, both in number of shares and in market capitalization or value, let's say.